Welcome to The Explainer. Today, we are diving deep into the magic of video streaming. We're going to reveal the clever tricks that shrink these gigantic movie files down so they can actually fly across the internet and land right on your screen. So, let's just start with the absolute core of the problem. Raw video is enormous. Seriously. We're talking gigabytes for just a single minute of footage. Trying to send that over your internet connection? Yeah, that's just not going to happen.
So how in the world does a full-blown 4K movie stream to your phone without making you wait for weeks? Well, the answer is a whole series of incredibly clever, cheats and hacks. The whole thing is called compression.
All right, so how do we even begin to shrink this stuff? Well, before any of the real magic happens, there's a fundamental choice that has to be made. It's a choice between two totally different philosophies for making files smaller.
Okay, so on one side, you've got the perfect packer. This is what we call lossless compression. Think of a zip file, right? You get a smaller file, but you lose absolutely nothing. It's perfect, but the file doesn't get that much smaller. And then you have the smart artist, which is lossy compression. This approach is totally different. It knows exactly which parts of the image you can just throw away permanently because it knows you're never even going to notice they're gone.
So let's get right into it. Every single video you watch online, every stream, it makes a really bold choice. It cheats. It uses lossy compression. But here's the thing, it's not just randomly throwing data into the wind, it cheats intelligently. So if all video streaming is built on this really smart cheat, where does that smarts come from? Well, this is what's so fascinating. The biggest secret to video compression isn't in computer code at all. That's right, the secret is our own biology. This entire incredible system is built from the ground up to exploit a fundamental flaw. Or, maybe it's a feature, depending on how you look at it, in the way our eyes actually see the world. So to pull off this biological hack, engineers had to stop thinking about pictures in terms of red, green, and blue. Instead, they split the image into two different things: brightness, which they call luma, and color, which they call chroma. Now the luma, that's where all the detail is. All the textures, the sharp edges. The chroma, well, that's just the color. And this coloring book analogy is just perfect. Think about it. The detailed black and white outlines are what really define the picture for your brain. You can be a little sloppy with the crayons you use to fill it in, and the image still looks totally fine because those super important outlines are all still there. So, armed with this incredible insight about how our own eyes work, video compression is ready to make its first huge move. And this is where we get our first absolutely massive reduction in the file size. You see, the crucial point here is a simple biological fact. Our eyes are insanely good at seeing tiny little changes in brightness. But, and this is the key, we are surprisingly bad at seeing fine details in color. And that means we can get away with being much, much less precise with all that color information. This whole process has a name. It's called Chroma subsampling. And honestly, it's the first major heist in our compression story. We keep the high-resolution luma, those crisp outlines, but we just slash the resolution of the chroma, the crayon colors. Let's make this real. See the bar on the left? That's the amount of data you need for perfect, full color, what the pros call 444. Now look at the bar on the right. That's how much data we use after subsampling. It's a massive drop, and it's all because we're storing way less color info. So how much less are we talking? Well, with the method that's almost always used for streaming, called 420 subsampling, we keep all that critical brightness data, but we throw away a shocking 75% of the original color information. And because of how our eyes work, we barely even notice it's gone.
And the payoff for this one trick? A staggering 50% reduction in the total image data. Just like that, we've cut the file in half before we've even done anything else, all by just taking advantage of how our eyes work.
Okay, cutting the file in half right off the bat is a huge win, but we are nowhere near done. The next job for the compression engine is to become a detective, to hunt for patterns and get rid of anything that's repetitive. Engineers have a word for this: redundancy. Now, this redundancy comes in two main flavors. First, you've got spatial redundancy. That's repetition inside a single picture, like a big patch of blue sky. Then there's temporal redundancy. That's repetition over time, from one frame to the very next. Well, let's talk about spatial first. It's a really simple idea. Pixels that are right next to each other usually have a very similar color. Think about a close-up on someone's cheek or a plain wall on the background. From a data perspective, those areas are pretty boring and very predictable. So instead of wasting a bunch of data by storing the exact color of every single pixel on that wall, the system uses a little prediction trick. It looks at the pixels nearby and just makes an educated guess, basically saying this whole block is probably this one shade. And storing that one simple guess is way more efficient than storing hundreds of individual pixel values.
And the exact same idea works for things that don't move over time. I mean, if you're watching a news anchor and the background isn't changing, why on earth would you waste data redrawing that same background 30 times every second? You wouldn't. The system only needs to describe the parts of the image that are actually changing, like the anchor talking.
So you can really see it's this multi-layered attack on the file size. It starts with biology, right? Hacking our vision with Chroma subsampling for that huge 50% cut. Then it moves on to math, using prediction to get rid of repetitive patterns inside each picture and then between pictures over time. This layered strategy is the absolute foundation of all modern video streaming.
And all of this leaves us with a really fascinating thought. Our entire digital streaming world isn't just built on what our eyes can perceive. Maybe, just maybe, it's built even more powerfully around the things we can't perceive. It makes you wonder, what else in our digital lives is defined not by what's there, but by the built-in limits of our own perception?